Well, here we are for part 3, working on the old Case 580CK. We're working on the backhoe swing going rogue on us. If you haven't seen parts 1 or 2 yet, well, that's the beginning of the story. So just a quick review. Here's one of the 2 swing cylinders with its trunnion pivot system. And they were worn out, so we replaced that hardened bushing in there. And this trunnion shaft flange was worn out too, so we built it back up with welding, took it to a machine shop, and had it turned down on a lathe back to the original factory size. 3 needed this done, and the other one was okay the way it was. Came out real nice too. Here's the new pressed in bushing and the new flange shaft.
Nice fit.
Then for the damage inside the cylinder, the places sticking out, we used a hone to smooth it down. And for the damaged threads in this rod, we chased them out clean with a tap. Then we installed new bushings on the end of each rod because they were very worn out too. And the old pin is good enough to keep, so all we had to do then was prep it up with some primer and ready for the paint shop. But before we got this far along, there was one little itty-bitty thing we had to take care of. Remember in part 1 we were talking about this grease fitting getting smashed up on the swing cylinder rod ends. The book shows there were 2 different versions to grease this bushing. One was like this on the rod end, and the other one was a grease fitting on the end of this pin with a channel going up into there. So it looks like we've got a backhoe frame that was for the pin grease fitting, but we've got rods and pins that get greased on the side like this, and it's whacking on the frame every time it goes from one side to the other all the way. So what I'm going to do is plug up this original grease fitting hole and move the grease fitting hole back a little further, and hopefully it'll clear the frame. It's 1/8 inch tapered pipe thread, so I just got a plug and screwed it down in there, cut it off, made it smooth. Probably noticed that weld job on the rod to the end. Looks like a in-the-field emergency repair, but it's been holding for years, so I ain't gonna touch it.
Looks aren't everything.
So I'm gonna run a pilot hole down through here, and I want to stay away from the rod, but I don't want to be right next to the old grease hole either. And I don't want to make as big of a hole as that old one, so I found some 1/4 inch 28 grease fittings that are tapered. So if I just tap a regular 1/4 inch 28 thread hole, the grease fittings will get tighter as I screw them in. Always a good thing with grease fittings. So hopefully this grease fitting will be out of the way of the backhoe's frame and won't get whacked anymore. And I don't want to forget to deburr the inside of this hole. Could have been done any number of ways. That's the way I did it. Looking over both of these swing cylinder rods, I'm starting to notice there's some differences between the 2 of them. The first difference is that one is about 1/8 of an inch longer than the other, which may or may not turn out to be something significant. We'll see. Here's another difference between the 2 rods. The end of this one looks normal like all the other cylinder rod ends. It's got a nice broad flat face on it to sit against the piston half, or in this case, the spacer washer that sits against the piston half. And this is all being squeezed down with 700 foot-pounds of torque when it's all reassembled. So a wide, flat surface there on the rod end is the way it's supposed to be. Okay, now let's look at this other swing cylinder rod end, and this is the one that fell apart in the tractor. Look at that narrow, rounded off end. Not much wide, flat piston support there. Look how long this taper is. Well, this is the rod that's too long also, so I think I can fix both problems with one operation. I'm going to shave that end down until I get a nice broad place for the flat washer, and it'll make the rod shorter to match the other rod. So here it is all done. Have a machinist do it. Got a nice surface for the flat washer. Made it 1/8 of an inch shorter. But now there's a few issues with this piston half we have to deal with. Remember, it got damaged when the cylinder fell apart on the tractor? That face inside that piston half is rough, so I also took it into the machinist and he chucked it up in his lathe. It just took him a minute. He faced off that surface right there and made it flat and smooth again. Well, the final issue with this piston half and rod that's odd is that it's too tight to put on by hand. I had to really pound hard to get this piston half off when I disassembled it. On all the other cylinders, the piston halves are not that hard to take off. I never showed it on camera, but we did see this. When I tried to take this gland off, it slid okay till the very end, and I couldn't get it off, and so I had to pound it. Well, it was the same getting the piston half off. Turns out that the last 2 inches or so of this rod is bigger than the rest of it. Very strange, and possible clues as to why this cylinder fell apart inside in the first place. So one scenario is that the last person who overhauled this cylinder, when they thought they had 700 foot-pounds of torque on that bolt to hold a piston and rod together, the piston wasn't even pushed all the way down on the rod yet. It was that hard for me to pound that piston half off. Now, whether that scenario is how it really happened, I don't know. It's also possible that the bolt was not torqued down to the full 700 foot-pounds. But regardless, I've got an idea for bringing the end of this rod down to size so the fit will be correct. The difference in diameter is barely 0.02, but that's the difference between an easy fit and a hard press fit. This surface layer is hard chrome, but I think I can take it down enough with some sanding. I'll do the old shoe shine trick. And I've already done it, but I'm just kind of going through the motions here for the camera.
Round and round and round.
Look at this abrupt edge here that could likely damage the new seal kit when I rebuild the cylinder. So I'm going to sand that down smooth too right now. Then repeat the whole process with a little bit finer grit sandpaper. I know I'll have gone far enough with the sanding when I can put this gland back on. Look at that. There's no difference in how hard it is to slide it on at the beginning or further down.
That's how it should be.
And likewise, this piston half also fits down on there more like it's supposed to.
Nice.
So now I think these two rods are matched together more alike, and maybe we've even solved the mystery of why the cylinder fell apart in the first place.
Maybe.
Okay, this is just in general about hydraulic cylinders. And say you've got one that's leaking hydraulic fluid where this rod comes out of the cylinder. So you install a rebuild kit with new seals and hopefully fix the leak. But if you've got scratches going down the rod like this, the rebuild kit is not going to stop the leaking. It might stop it for a while, but not for long. And the scratches don't even have to be a bunch like this. It could just be 2 or even 1. And it's worse if they're long, continuous scratches like this, rather than just short little dents. So to properly repair this cylinder and stop it from leaking, This rod would have to be either reconditioned with a new surface or completely replaced, which is getting kind of pricey compared to a rebuild kit. Now I've got my own ideas about what is causing these scratches, and I think it's the sand and grit intruding inside through that little gap on this rod wiper. This wiper is the only defense against sand and grit going inside the cylinder when the rod slides in. And this gap looks awful suspicious, allowing contaminants to get inside, cake up on the seal, and then just scratching the hell out of the rod every time it goes in and out. I've noticed that cylinders on this tractor that are inclined upward have more of a scratching problem than ones that are horizontal or pointing downward, which makes sense if this is indeed how the debris is getting inside. The factory book shows the 3 different types of rod wipers and seals, and style 2 is what we have. The style 1 above it is the same basically, except it has some O-rings there that don't really help out our problem. So this style 2 is what we've been talking about, and there's the snap-in rod wiper. But the company must have realized there was a problem, because then they made this style 3, and it's got a press-in rod wiper that doesn't have any gap. Here's an old used one on one of our cylinders, and it's a continuous seal all the way around. Here's one removed. It's a steel ring that you press in, and then it's got a hardened rubber seal that wipes the rod off and keeps crap from getting inside. Because once debris is inside, it can collect easily on this seal, or any place really that's further in here.
And it accumulates there and scratches the rod.
This style 3 looks like it would be a much more effective wiper. Lately, since I've been doing this work, I've started noticing other professional heavy equipment out in the field, and I see they've all gone to great pains to make that wiper be extra thick. Maybe there's even an inner and outer wiper, multiple layers of protection. They're sure gonna perform leak-free for a lot longer than the snap-in split wipers that we've got. If I was really serious and I had access to a lathe, I would cut out that bigger space for the press-in wiper and make my style 2s all style 3s.
Oh yeah.
Now with short little dents like this, I'm going to try the old JB Weld trick and see if that helps. It might work for a while, I don't know. But for these scratches, they're too shallow and thin to get a good bond with any JB Weld, I would think.
So get the rod reconditioned with a new surface, get a new rod, or put up with the leaks. Ho, 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 ho.
Another related issue with these Style 2 glands is that they let not only debris in, but they let water in, and you get this rusty pitting down here where the seal is installed, and also over here where the wiper is installed. And again, the damage is more severe on cylinders that are pointing upwards on the tractor. The problem is when you go to rebuild these, if they've got the rough pitted steel there and you put a new seal kit in, the hydraulic fluid in the cylinder is likely going to leak around the seal where it's pushed up against that pitted steel. So, what to do if I'm on a budget and I need to get this tractor back online? Well, I'm going to try a way where instead of putting grease in there when you assemble the kit, I'm going to use a silicone gasket sealer between the seal and the pitted metal, and the same for the snap-in wiper and the pitted metal. The next mechanic that overhauls and rebuilds this isn't going to like me, but that's what I'm going to do. Actually, it shouldn't be that bad for the next mechanic, because he's going to have to do what I'm doing here to get the rust and stuff out. He'll have to do it to get the gasket sealer out. They've got these wire wheels in fine and coarse, and they're narrow enough to fit down in that groove back there where the seal goes. So it can be cleaned up to shiny metal pretty good. But if it's rough and pitted, that's where I'm going to use the silicone gasket sealer. Now here's an example of how it might look if there didn't get any rust. This is the inner wiper slot, and it cleans up real nice with a fine wire wheel. But there's some dings and dents here. I don't know what these are caused by. Somebody beating it with a hammer, or something loose was in the cylinder, but they're sticking into the circle a bit. So I'm just going to use this chainsaw file and take their high spots down. There's one more place on here that needs to be checked out for cleaning up. It gets rusty. It's right here along this groove. It's the O-ring, and there's a backup ring too. And right where it stops the water from coming in, it gets a little rusty. So that could be cleaned up too with a wire brush. So when looking it over, this part out here, if it's pockmarked from rust, that's okay. This next part, that's okay too, as long as there's a nice clean spot right next to it here, and that's where the O-ring sits and seals the inside from the outside. There's got to be a clean, smooth place there. Actually, when we took these apart, we found that there were two backing rings behind the O-ring when there's only supposed to be one. And that moved the O-ring further over to this smooth place, which seems like an excellent idea I'm going to duplicate. Now, in addition to that, the best chances for getting a good seal here is to use a liberal amount of grease on the O-ring, the backup ring, and the metal when it's being assembled. Here's another kind of gland damage that has to be dealt with. This was removed and installed when the person didn't have the real gland wrench, just using any blunt instrument they had. Sometimes that's the way it is. This is the real gland wrench, and we used this in part 1 if you remember. It has a hole for 3/4 inch drive breaker bar, and then it has these pins that are removable. One's larger and deeper than the other one. The smaller pin fits all the glands on this tractor. And obviously these holes are so badly damaged that this wrench isn't going to work anymore. So there's a couple choices. If these aren't messed up too bad, you can drill them out to the bigger size, or you can drill 4 new holes in between the old holes. And that's what I'm going to do, and I'm going to make them bigger for the bigger pin. The bigger pin's great because it's also deeper. It's a real sure grip compared to the smaller, shallow pin. So here it is all done, 4 new holes, plus I found that 2 of the old holes could be cleaned up okay with the bigger size drill for the bigger pins. Extra places to put the gland wrench in different positions is never a bad thing. The 2 unusable old holes, I just filled them in with caulking. And I did first sand down all these old holes so they were flush with the rest of the surface. Now here's another gland, and the holes aren't messed up too bad, but I like the deeper, bigger pins on the gland wrench so much that I'm just going to make all the bigger glands on this tractor have the bigger size holes for the bigger pins on the gland wrench. The bottom of the original hole is the right depth. Okay, now focusing back specifically on the swing cylinders, I'm going to do a dry run mock-up assembly of this cylinder. There's a lot of things similar to this swing cylinder and all the rest, the cylinders on this tractor. But remember, like I've already mentioned and I want to emphasize again, The swing cylinder is more complicated, it has more parts, and some of the parts that were missing or broken were hard to find, such as this hardened tapered pin that used to go in the bolt that screws the piston halves to the rod, and that pin pokes into a hole in the back of the cylinder whenever the swing is all the way to one side, which then activates this relief valve, keeping the backhoe swing from slamming at the end of its travel. It makes it a cushioned, gradual stop. The first item I couldn't find anywhere was a replacement for this bent spacer washer. It's hardened and it's a certain thickness. I ended up making one, and the way I made it was I realized that this washer on the bolt is available, and it's about the same thickness, has the same size hole, and it's hard. So I just cut the big washer down, taking little slices off with a metal cutting disc and an angle grinder, little by little, frequently pouring cold water on it so it never got hot, preserving its heat-treated hardness. Finally ending up with the angle sander to finish off the outside diameter to its final size. Again, keeping it cool with water the whole time. Alright, the next odd piece for this swing cylinder is this spring. And found out by looking at the book that it was missing these little spacers that go down in the bottom. And it's just a flat platform for the spring to rest on, and also makes the spring tension just so. The only thing to watch out for when loading up this spring is to make sure it doesn't catch on one of the steps going down in there. Make sure it's all the way down in. Okay, the last remaining hard to find weird part for this swing cylinder is this pin. Remember it was bent and busted? Well, nobody had this in stock anymore. But one of the suppliers went on the net and found that there was Yukon Equipment in Anchorage, Alaska that said they had one. And by golly, they did, and they shipped it down to me. And it's the exact right one.
And it's an original case part, too.
It may very well be the last factory new pin on the planet. Wasn't cheap either, over $150.
Ouch.
And of course, just like almost everything else on this tractor, it couldn't have just gone that smooth and easy. If you'll notice, that pin is kind of cockeyed in relation to the center line of the bolt, and that means it's not going to hit this hole in the back dead center when it's in the tractor. And what I think's going on is that this step on the pin is coming up against some debris there caused by the original cylinder falling apart. So I'm going to use a little homemade end mill I made from an old drill and try and clean up that debris and make the bottom where the pin sits flat and flush again. A replacement for this bolt is over $65 plus shipping. I think I'm going to try this first. This was just an old 5/8 drill bit from the wildfire. I sharpened the end to be a mill and heat treated it so it would be hard again. Gave it a few turns with the drill, and now instead of it being cockeyed like this, if you relax it and just hold it, now the pin comes out straight and true.
Voila.